I'm going to talk about objects, classes, and their relationships in programming. Welcome to this presentation, which covers the fundamentals of objects and classes in programming context. These two concepts form the foundation of object-oriented programming, a powerful paradigm for software design and development. Relationship development. Well, first of all, an introduction to the programming objects and classes. Well, what is an object? Object being the basic unit of the object-oriented programming, encapsulate data and the operations that manipulate data. They offer a way to organize code and improve code usability and maintenance. Now, classes. A class is a blueprint or a template that defines the property and methods common to all objects of a certain kind. The class is an abstraction and an ideal form of object for creating an instance. Finally, an advantage of OP simplifies the programming structure of identity program and improves the performance of the same. It makes code modular, reduces the redundancy, and allows for code reusability without compromising high-level functionality. Now defining objects and classes in programming. Class definition. We have a class provide a blueprint for object creation, so it's essential that the definition is well defined. A well-defined class definition abstracts appropriate methods and properties. Continuing with this, we have the constructor function. The constructor function creates a new object that is an instance of the class definition. The constructor function initializes the object with the desired state of the given object. And finally, the object instance. An object instance is an instantiating an object from a class, while object instances are independent. Once an object is instantiated from a class, it can be modified and used in any part of the code. Now mention some relationships between objects and classes. There exist three important relations. First of all, we have composition, a relation where an object contains another and the contained object cannot exist without the container object. Aggregation, also known as part of relationship, the relationship between two objects where the part can exist without the whole. And finally, the inheritance, a relationship between two classes where one class is a specialization of the other class, inheriting all properties and methods from the superclass. Now we'll explain inheritance in object-oriented programming. Inheritance is a fundamental concept in object-oriented programming that promotes code reuse and enables to create hierarchical relations between classes. Let's now divide into three important types of inheritance: single, multiply, and multi-level inheritance. First of all, single inheritance. In a single inheritance, a class inherits properties and methods from only one base class. This allows for a straightforward relations between classes, promoting code reuse and extensions. For example, a car class inherits from a vehicle class. Well, now, multiple inheritance. Multiple inheritance allows a class to inherit from multiple base classes. It facilitates code reuse and compositions but requires careful handling to avoid conflicts. For example, a guitarist class inherits from both persons and musician classes. Well, now, multiple inheritance. Multiple inheritance involving inherit from the derivable class, creating a hierarchical structure. It allows for a complex relations and promotes code organization and modularity. For example, a dog class inherits from Marma, which in turn inherits from animal. Well, now we're gonna talk about encapsulation and abstraction in object-oriented programming. Encapsulation refers to practice of building data and the methods that manipulate the data within a single unit. As we know, programming-oriented objects have objects as a single unit. Now, abstraction involves defining concepts and behaviors at a higher level of abstraction than their implementations. And finally, access modifiers. Access modifiers provide the functionality to restrict or grant access to fields, attributes, methods, and classes to allow it scope during the encapsulation process. These include private, public, and protected. Polymorphism is a key concept in object-oriented programming that allows objects of different class to be treated as objects of common superclass. It provides flexibility and extensibility to object-oriented programming systems, enabling the development of more modular and reusable code. Let's explore polymorphisms and its significance. The definition of polymorphisms is that refers to ability of an object to take on multiple forms or have multiple behaviors. It allows objects of different class to be treated uniformly when they share common superclass. Well, now talk about the types of polymorphism. First of all, it involves the use of functions overloading and operators overloading. Function overloading enables the creation of multiple functions with the same name but different parameters. In the other hand, operators overloading allows the customization of operator behavior for different data types. Well, now in runtime polymorphisms, we have that it's achieved through methods overriding and virtual functions. Methods overriding allows a superclass to provide implementations of methods inherited from the superclass. Virtual functions ensure that appropriate methods is called basis of the actual object type at runtime. Importance of polymorphisms. Well, first of all, the code reusability. This is because polymorphisms promotes code reuse by allowing different objects to be treated uniformly through a common interface. As well, flexibility and extensibility. This is because flexibility in accommodating new classes without modifying existing code. It allows for easy extension of functionality by adding new classes that adhere to common interfaces. Simplify code maintenance. And finally, runtime decisions. Polymorphisms enable decisions to be made at runtime based on the actual type of the object. This dynamic behavior allows adaptable and context-specific execution paths. Well, here's an example. Consider an scenario where we have a base class called shape. We derive classes such as circle, square, and triangle. By treating these objects an instance of the common superclass, we can write generic code that can perform operations of any shape, such as calculating area or displaying the shape. Well, we now will check some examples of implementing objects and classes in code. Well, first, as we have mentioned before, creating a car class. Creating an object of a car that defines the behavior of a car has like the ability to start, stop, and look at how fast it's going. On the other hand, we have extending an animal class, creating a dog object from animal class to define the unique behavior of a dog, like chasing its tail and barking. Well, finally, a bank account class, creating an account object with methods of adding or withdrawing money, checking the account balance, and tracking the account owner's information.